Okay, boys and girls, today we're going to look at applications of right triangle trigonometry. Yesterday we learned the three ratios of a right triangle trig, and the first one was sine theta, and we said that sine theta was equal to the opposite side over the hypotenuse. And then we also looked at cosine theta, and we said cosine theta was the adjacent side over the hypotenuse. And then the last one was tangent of theta, which we said was the opposite over adjacent. Okay? And so today we're just going to take those ratios and apply them. So let's start by looking at this first example. We have a 2.7 meter ladder leaning against the house. So let's just kind of highlight the information that's going to be important. We have a 2.7 meter ladder and it's leaning against the house and it forms a right angle of 30 degrees with the house. Exactly how far is the base of the ladder from the house? Okay, so let's just kind of mark what we know. We know that it says the ladder is 2.7 meters, so that would be this distance. And we have to read this carefully. It says forming a 30-degree angle with the house. So that means that this distance is 30 degrees. And we're trying to find the distance from the house to the ladder. Okay? I'm just going to make that a little bit bigger so you can see it. All right, so I know that the 2.7 is the hypotenuse because it's opposite the right angle and it's the longest side. So this is my right angle. It's opposite the right angle, so it is the hypotenuse. So compared to this 30-degree angle, well, it doesn't matter, not compared to anything. This is just the hypotenuse. But compared to this 30-degree angle, this is an opposite side. That's an opposite side from the 30-degree triangle. So I have to ask myself, and we're trying to find that x. Which of the trig ratios will we use? Well, I have a hypotenuse and I have an opposite. So which one does that call for? If I have a hypotenuse and an opposite, I need to use sine theta. Alrighty, so we know that sine theta is equal to opposite side over the hypotenuse. So in our example, our theta is 30 degrees. So we have the sine of 30 degrees. The opposite side is what we're looking for. We're going to call that x. We've called it x. And that's going to be over the hypotenuse of 2.7. So how do I solve for x here? Because I have everything else, I need to solve for x. I need to multiply both sides by 2.7. And when I multiply both sides by 2.7, I get x is equal to 2.7 sine of 30. Okay, so I'm going to grab my handy dandy calculator. Again, one of the things I'm going to do as I grab my calculator is just to make sure that it's in degree mode. So how do I make sure it's in degree mode? I press mode. And then I notice it says degree. There's radian and degree, so I am in degree mode. If I weren't, I would just move my arrow key over to hit it and then press enter. All right, so I can second quit out of that now that I know I'm in degree mode. And then I'm just going to put this into my handy dandy calculator. If it will move, there we go. And so in my calculator, I'm going to put 2.7 sine 30 degrees. Close that parenthesis, press enter, and I get that x is 1.35 meters. So from the house to the ladder is 1.35 meters. Okay? All right, let's do this next problem. I'm just going to move this over a little bit. They didn't give me a nice, pretty picture with this one. Okay, so I'm going to have to draw my own picture. It tells me that the number of feet in the length of a shadow cast on a level ground by 15-foot vertical pole. So I have a pole. Don't laugh at my drawing. I'm not the best at this. So I have a vertical pole, and it has a shadow on the ground And it tells us that to the nearest in the number of feet in the length of the shadow. So I'm looking for this x. I'm told that the pole is 15 feet and that the angle of elevation with the sun. So the angle of elevation would be the angle that lies on the ground. So that is 53 degrees. Okay. Now in the next video that you watch, you're going to get more information about the angle of elevation. But using the angle of elevation, we get that we need to decide which trig ratio we're going to use. Well, what do I know? I know the height. So with this 53-degree angle, this would be an opposite side. And this x, because it's adjacent to that angle, this would be the adjacent side. So which trig ratio do I use when I have opposite and adjacent? If I have opposite and adjacent, I'm going to use tangent. So I will have that the tangent of 53 degrees is the opposite side over the adjacent side. Now this was going to require just a tad bit more work, not much. Because my x is in the denominator, I'm going to cross multiply both sides. So when I cross multiply, I get x tan 53 is equal to 15 times 1, which is just 15. To get x by itself, I have to divide by tan 53. So I get x is equal to 15 over tan 53. And to determine that, I'm going to use my handy dandy calculator. I already know that I'm in degrees, so I'm going to do 15 divided by tan 53. And I get 11.3. Okay, just making sure I read that right. 11.3, and that would be in feet. So the length of the shadow is 11.3 feet. I'm always going to go to one place behind the decimal here. I know I went two there, but generally one place behind the decimal is sufficient. Okay, let's do two more. We have a ladder leaning against the side of a building. So I'm just going to say this is my building because I'm being lazy. And I have a ladder leaning against the side of that building, like that. And the ladder is 10 meters long. So that's 10 meters. Now remember, this is my right triangle. So you can already see that that 10 meters is going to make my hypotenuse. And the angle between the ladder and the building, which would be this angle, is 18 degrees. Because this is the building, that's the ladder, so that's 18 degrees. How far up the building does the ladder reach? So I am trying to find out how tall the ladder is from the ground, which in this case, we're going to call it x. Okay, so if I have this angle, let's make that darker. This is the angle that I have. I'm trying to find this length. Right? So this length is the adjacent side. So I have an adjacent and I have the hypotenuse. Which trig ratio should I use when I have the adjacent and the hypotenuse? Let's go back up and look. If I have adjacent and hypotenuse, hey, look at this. I'm going to use cosine. Okay, so let's go ahead and set that up. I know that cosine of theta is equal to the adjacent side over the hypotenuse. Okay, so my theta is 18, so I know that the cosine of 18 degrees, my adjacent side is x, and the hypotenuse is 10. So to solve this, all I'm going to do is just multiply both sides by 10. So I get x is equal to 10 cosine 18 degrees. And then I go to my handy dandy calculator. I know I'm in degrees, so I do 10 cosine 18. And I get 9.5. Again, what units were I using? Meters. So I get 9.5 meters. Okay? All right, let's do one more, and then You can watch the second video and then practice. We have a lifeguard sitting on a tower, and we want to find the distance x. So we're looking for this value to the nearest tenth of a meter, and it tells us that this angle, so we can look at this like this. This angle is 41 degrees. Okay, and I know that the height of this is 3. So this height that's 3, that's an adjacent side. That's an adjacent side, and we know that this x is the hypotenuse. So once again, we have to ask what relates. We know that this is the hypotenuse, and we know according to that ladder, this is the adjacent side because the angle we're looking for is right here. So if I were to redraw that, because this may be confusing you a little bit, the angle would look like, the triangle would look like this. We know that this is x. This is 41 degrees, and this height is 3 meters. Okay? So I have an adjacent side, and I have a hypotenuse. So an adjacent and an hypotenuse, that means we're going to use cosine. So we have cosine of theta is equal to the adjacent side over the hypotenuse. So in our case, we have the cosine of 41 degrees is equal to the adjacent side, which is 3, over the hypotenuse. Now, anytime we get our x's in the denominator, it does require just a little, 1 second of more work. We're going to have to cross multiply, so I get x cosine 41 is equal to 3. So to solve for x, I'm going to divide everything by cosine of 41. And I get x is equal to 3 over cosine 41. And once again, I'm going to use my handy dandy calculator to determine that value. So that's 3 divided by cosine 41, which is 3.97. So we're going to round that up. That'll round up to about 4.0. So about 4 meters. Approximately 4 meters. Okay, that's it. That's how we use sine, cosine, and tangent in applications. Please watch the next video on angle of elevation and angle of depression. Thank you very much.